All right, guys, I'm going to post an announcement to this effect, but grades from the Mindtap programming problems continue for some people to not be reflected in Canvas. So we're going to take a new reproach. I like that. I would like to give Mindtap a reproach. But what we're going to do now is we have folders for Chapter 2 and for Chapter 3. And we're going to go in there, and you're just going to upload a screenshot showing that, you did problems 1 through 4 of Chapter 2, and that you did these problems for Chapter 3, and so on. And if you didn't do them all, you're just going to upload a screenshot anyways. Just a sec. If you go back and you do some more, just upload another screenshot, and your grade will be increased. And so these individual links to the problems are going to disappear, unfortunately. But the folders for uploading the screenshots will be here with a due date. So, like, for example, maybe by the end of spring break for Chapter 4. Yes, sir?
So do we need to upload screenshots if it is working for us?
Yes, please do. Just upload screenshots anyways. Pretend that the connection between Mindtap and Canvas is being completely excised except for the quizzes.
Okay.
That makes sense. I'll post an announcement to make it real clear that that's the case. So it's awesome that it's working for you, but lots of other people aren't having it work. So I really have two choices. One is to go into the grades one by one, or the other is to remove the grades from Canvas.
I would like to say that for mine, the reason why mine probably didn't do it is because I did mine before they were set to be 4th grade. So I don't know if that's why.
What would happen if you went back in and
I
did
tried
that? Okay.
and it doesn't,
Okay.
yeah.
Okay, so I still want to do it this way.
Okay.
I still want to do it this way.
Yeah, plus Mindtap, if you don't do it a certain way, it just gives you a flat 0.
Yeah, you were having problems with one of the problems, and that one confused me. And I meant for us to stay after class and look at it, didn't we? Or did we figure it out? I don't remember. If you're still having that problem, just hang out after class.
It wasn't the Mindtap problem.
Oh, okay. Alrighty.
And plus, I experienced that in fundamentals.
Yep, that's very true.
So.
Okay, so looking at Mindtap problem 4.1, let's get a clue to how difficult these problems are. Write a script that inputs a line of plain text and a distance value and outputs an encrypted text using a Caesar cipher. The script should work for any printable characters. An example of the program input and output is shown below. We have done this. We have done this exact same thing in our notes. So problem 1 should not be too difficult because, like I said, we have done the exact same thing in the notes. I will put our code into this problem, make sure that our algorithm actually solves it, just to make sure that it's a good one. But if you go back in our notes, you'll find the exact same code. How would you do it? You're just going to step through every letter of the input string, modifying its ordinal value based on the shift amount. Like I said, I'll enter our algorithm that was in our daily notes to make absolutely sure it meets the requirements. And I know Jacob's done it, and so I bet several of other folk have. So that's a good problem to do. Write a script that inputs a line of encrypted text and outputs the plain text. Same business, except you'll have to shift it the other way, right? Because if you say you want to do the distance value of 4, you're just going to shift everything with a -4. Show the plain text for it. Again, I'll enter our algorithm that we did that day in our daily notes to make absolutely sure it works. So that one's a good one.
So we talked programs similar to what we have in our notes.
Exactly, that should do it. Modify the scripts for 1 and 2 to decrypt and encrypt an entire file of text. An example of the program is shown below in the interface. That's what we're talking about for a little bit. Enter the input file name, encrypted.txt. Enter the output file name, A. Enter the distance value. So, how's it going to work? You've done this one, right? How do we pick which file? I mean, how do we say the data that's in the file encrypted.txt, or do we just use that one? Did you do this problem?
I did stuff in chapter 2.
Let's run it and see. No, that's not the right one though, right? Because it's asking for the file name. Tell you what, let's poke around with this one a little bit. Let's see if we can just open a file and print the results out. Oh, I'm going to nuke all that, although that happens to be the answer to one of the problems. I'm surprised it's there. Alright, so let's open up encrypted.txt. So let's ask for the file name, right? Fname is equal to input, parentheses, quote. Here's a, you know what I'm going to do? Exactly copy that, even including that little space. Paste that into my input. Let's open that file. I mean, I could ask for the rest of these things too, right? But I'm not going to actually code the problem. So, you know, here's the output file name. I'm going to call it out file is equal to input, parentheses, enter the output file name. I said I was going to put the space there. It didn't wind up there. All right. And then enter the distance value. Sure, why not? I'm going to call it the shift is equal to the integer version of the input, the distance value. Copy and paste that. All right, now let's open the file name that they asked for. We're going to open fname for reading. We're going to open out file for writing. I've changed my name. I'm going to call it in file and out file. No, I'm not. I think I'll call them I file and O file when I open them up. So I file is equal to open the input file name. My variable names could use a little bit of help for reading. So fname, comma, quote, F. Let's open the output file. O file is equal to open parentheses fname, comma, quote, for writing, end quote, in parentheses. Now I'm just going to read in the entire file into one string, just to test, just to see what's in there. So S is equal to open, S is equal to ifile.read. Remember that if you do .read, it reads the entire file in. And then we can just print that out. That's our first step to see how this works. Just to make sure there really is a file called encrypted.txt that we have access to. It's fascinating to me that they give you the answers for problems 1 and 2. I don't think that's a correct answer. No, that one absolutely is not a correct answer, because it wants only lowercase. Alrighty. Anyways, let's run it. Let's see how this goes. Where's my green arrow? Excuse me, where's my blue arrow for running it? Well, fine. I'm not seeing either one of them. Am I crazy? Where's the run arrow? Okay, fine. I'll execute the tasks. But I really wanted to see the output over here. Run the checks. Yeah, of course it failed. Ungraded. You have to create the file for the text. Okay, so I'm going to create a file called encrypted.txt. Encrypted.txt, create the file.
It doesn't do
A,
that
B,
for
C,
you?
D. Yeah, it apparently doesn't. A, B, C, D.
I don't like that.
Yeah, I'm not too fond of that either. Alrighty. Run the checks again.
Of course it failed.
Oh, let's see. I need to do something before we actually get this going. Let me skip this one as an assignment. I'm gonna skip that one. I'm not gonna assign it because I'm not quite understanding yet how to actually get it to read from the input and output. I would like to be able to do it, but I don't want to spend or make you spend an inordinate amount of time trying to figure it out. I am going to peek back in case there are other programming problems that rely upon the same mechanism of needing these input and output files to run. So I think it did it itself. I think they created that file themselves, because when I looked here, create the file for test, and then they ran encrypt.py. This was their input. Open up txt for input, open encrypted.txt for output. And the output was not at all what we wanted to see. They're not letting us see how it worked. This one's fascinating. It says that we got it correct even though we definitely did not write that program. Yeah, we're skipping this one. No such file or directory. Would I have to create a decrypted.txt myself? Yeah, I'm skipping this one.
It's too hard.
And it's just kind of squirrely with the creation of the files. I'm not trusting that it will work correctly. I don't like the fact that I don't have a run button myself. So octal numbers have a base of 1 through 8. Write the scripts octal to decimal and decimal to octal.py, which converts number between the octal and the decimal representation of the integers. Okay, yes, you could do that, but you sure could also. Okay, I guess they want us to use the exact algorithm that they put in there. There's the answer. Why do I have all the answers? Put away your cameras, guys. I don't want you watching these. I don't want us to write a problem over octal. Let's skip that one.
Sometimes I think they just give you the code and they want you to edit specific.
To modify,
Yeah,
okay.
to get it to work.
A bit shift is a procedure where the bits in a string are moved to the left or the right. And then notice that the leftmost bits are shifted left around. Okay, this one's worth doing. Maybe it's worth doing together. Let's get the concept of shifting in hand. So I'm just going to open up some green text so that I can type. We're in lecture N. You're familiar with the idea of binary, like if you had that, right? Whatever. Then if you were going to shift that 1 to the left, all the bits would rotate. So it would be just like if I copied and pasted this, did that, right? Just like that. No, not just like that, because there was no 0 to fill this in. Okay, so take a look. Everything's going 1 to the left, so the 0 wrapped around to that 0. The 1 moved there, the 0 moved there, the 0 moved there, the 0 moved there, the 1 moved there, the 1 moved there, the 0 moved there, and that one had come from there. So if you were going to shift everything 2 to the right, starting from here, let's do that. So shifting 2 to the right. Again, I'm back here. Just going to copy that and I'm going to play with it a little bit. Since it's going to the right, these two things are going to go off the edge of the right and show back up over here on the left. And that's that. So how would we write that? Well, we would need to convert. Let's see what their sample input and output is. They want us to use text. Well, yeah, great, but until we get the idea of shifting, until we get some code that'll shift at all, why bother doing the bigger thing? So we're going to break the problem down into pieces. We want to write a little bit of code that actually does the shifting, where we specify a number, it converts it to binary, it shifts it, and then it recreates it. Now, there is a cheap and cheesy way of shifting, which is if you notice that you had this, and it's not going to work for us, by the way. If you had that, what is that in binary? There's no 1s, but there is a 2. There's no 4s, there's no 8s. So that's equal to 2. And then if you shifted that 1 to the left, like that, then it becomes this. Well, what is that? Somebody tell me what this number is in binary. Y'all get the idea, right? You remember these are the 1s column, the 2s, the 4s, and the 8s. So what is that? It's a 4, right? And then if it shifted again, it would be that. And what is that?
8.
Yeah, that's an 8. So shifting to the left is the same as multiplying by 2. Shifting to the right is the same as dividing by 2. So why not just use multiply by 2 and divide by 2? Why was the concept of shifting ever even implemented? Because shifting came before the rest of the math in the computers, in the 40s and whatever, because it was easy to, implement inside the electronics. So multiplication and things like that came later. Shifting came first. Your chip, your processor actually handles shifts much more quickly than multiplication and division functions. So how could we do this? We need to convert a number, whatever our number is going to be. I don't know, let's just call it value. We're going to start off with the value of 12. And when we're done shifting it, it should be 24. Multiplying by 2 is not allowed. So we need to convert it to a binary string. There are algorithms for doing that, and then there is just the idea of printing with a string. And I'm going to have to remind myself, Python format binary integer. Python string format method can take a format specifier. It's exactly what we want as far as I am concerned. You use a placeholder number, which you could probably even leave out, and then :B. And you pass it a number, and it gives you the binary. Let's test that out. So we're going to make a binary string, BS, it's a bunch of, no, I won't go there, is equal to, quote, curly brace, 0, because it's going to be the first placeholder, :B, which means convert it to binary. A D would be an integer, an F would be a floating point value, and S would be a string. I believe an X is hexadecimal. Have to look that up to make absolutely sure. So end quote dot format that value. And then print the value out. Just to see what we get. Oh, no, yeah, let's print the value, but also print the binary representation of it. This is lecture N. Alrighty, so 12 is 110 or 1100. Does that sound good? No 1s in it, no 2s, but there's a 4 and an 8, so that looks good. But we really want it formatted, as far as I'm concerned, 8 characters. Excuse me, 8 bits, because an ASCII character is 8 bits. So we need to find a way of putting leading zeros in to our string. because I don't want it to look like that. I want it to look like that. I want this to be formatted out to 8 zeros. And I can think of one cheap way to do it, which is just to get the length of this string and then multiply that. Yeah, I'm going to show you something that I'm taking advantage of, and it's probably not the best way to do this, but it is useful. If you do 3 times 4, you know what that result is. What if you do 3 times quote 4? What's 3 times quote 0? See what's going on here? I could take the length of that string, do 8 minus the length of the string to get a number, and I could multiply that by string 0. So let's do that. Our padding is going to equal, we need to calculate the difference between the length of the binary string. So length, or 8 minus the len, parentheses, bs, in parentheses, and then let's just multiply that. Padding is equal to padding times quote 0, end quote, and that'll generate a string. In this case, it's going to be 4 zeros in a row. Since we've already seen a sneak preview of BS and it was 4 bits long, the padding is supposed to be 4 zeros. And then let's add that, append it, well, prepend it. We're going to put it at the beginning of our binary string. BS is equal to BS plus, no wait, BS is equal to the padding plus BS. Now I'm absolutely sure that we could have just modified this output string to say I want you to have 8 characters wide and to be prepended with zeros, fill in all the spaces with zeros. We might go and look that back up. But I wanted you to get the idea of this, right? You can generate a string of any length if you want. You want to print, 80 dashes across the screen? Print this, now this is just for fun, but print 80 times quote minus quote, and, that's going to print 80 dashes across the screen. Now let's print value comma BS again and see what it looks like now that we have our 8 zeros. There we go. Okay, now the problem is probably easier than what I'm making it, because I don't see why we need to make a binary string unless that's what it specifically asks for. But instead they give us an ASCII character that you're supposed to shift left and right. Why don't we just shift left and right that value? Well, I guess the problem is that it would get to be over the maximum value, right? It could become more than the 8 bits allowed. And so they're doing it with the shifting that way. Okay, so suppose we wanted to shift this value. Let me copy this back to the regular code inside green text so that we can brainstorm about it. What if we had that number and we wanted to shift it 3 bits? Here's what I'm thinking. Take the first 3 with slicing, cut them out, take the next 5, and then append the first 3. See what I'm saying? So, in this case, and these numbers aren't going to be quite right, I need positions 0 through 3, and then I need positions 3 through the end of the string, and then I need those 3 again, right? But in this case, I don't really need those things, because this is getting moved to the end. Let's give that a shot. Let's just print that value out and see how it looks. Print our binary string starting with position 3 and going to the end of the string. That's what a colon means without a number. Start at 3 and go to the end of the string. That's what that means. And then we're going to pick up the rest of them. BS starting from the beginning of the string. And by the way, you can leave that 0 off if you want. But like I've said in the past, I don't see why I would want to. And in this particular case, I could probably go ahead and just put 8 because I'm assuming that this string is 8 characters long. But why not just make it generic? All right. And going out to our shift length of 3. Let's see how that looks. Let's see if it looks like it's been shifted 3 to the left. I think so, right? Because shifted 3 to the left, instead of 2 zeros, there should be 5 zeros. 1, 2, 3, 4, 5. So to get this to work, we just need to substitute our shift value there instead of 3. So let's hard code that for now. Shift is equal to 3, and let's rewrite this expression replacing the number 3 with the word shift. And by the way, it's okay if you're not getting this 100%. I'm hoping that you are getting some of the concepts. I like you to have this idea in your brain, right? That you can multiply something out to get, this even works for lists, by the way. If you want to create an array that is composed of 80 zeros in a row, and if you've ever taken a programming course and you know what an array is, then you do something to that effect. Let's test it out. The other thing that I want you to know is slicing. Slicing is incredibly important because you do it with strings and you do it with lists. And slicing is what made it worth talking about this for for 20 minutes. Okay, that did give us the result that we wanted, in my opinion. We could read that back in as an integer now. We could convert it from a string back to an integer just using the int command, right? So our final number, that's kind of too long of a string, right? Final num is equal to the int version of that string, of our bit string, but not in base 10. So we're going to put comma 2 because that's base 2. Convert bit string to integer using base 2. Using base 2. Now that's going off the end of my screen, right? But you'll know that it's there. And let's print it out and see if we like it. So print the final num, just to see if we're going in the right place, make sure we have no syntax errors. Alrighty, I'm not expecting that as our answer, but the reason why is because I forgot to make this our new string. I skipped an important step. I showed that we could print it out, but I never actually calculated it. So do this instead. Instead of printing that bit string out, make it say BS equals, right? We're building our new bit string there. And you can take out the parentheses if you want. Right, because now that it's not a print statement, it doesn't matter anymore. Okay, 12 shifted 3 times is 96. Because you're doubling it 3 times, just like I mentioned. Tell you what, let's just make the shift 1, because we know that a shift of 1 is just a doubling, and then a shift of 2 is multiplying it by 4. Let's see. There we go. 12 became 24. Very good. Now what's the very last thing we would do is we would maybe need to turn this into a function so that we could put it inside a loop. How do you make things a function? You use a def keyword. And then you would tab all this stuff, and it would need to take the original value as a parameter. Sounds like a lot of work, but trust me, it's not going to be too much. This variable is going to need to be passed in. So we're going to use that as our parameter variable. So do this. Def shift bits parentheses value in parentheses colon, and then get rid of that equal 12. See, now we've defined a function that accepts this as its parameter. And then we better shift everything we better tab everything underneath it. Absolutely everything all the way down to the bottom of our program. Just hit highlight it all and hit the tab key, or if you really like, you could choose format indent. Does the same thing. Boom. And we need to return our final number. That's the very last thing, because we've calculated a final number. We need a return statement at the bottom to get it back out. Like that. Now these comments and these print statements aren't necessary anymore. I'm going to delete those comments. You're going, well, I went to the trouble of typing them in. Well, sorry. And I'm going to comment out these print statements in case we ever need them again for debug purposes. Now let's try it out. Let's shift the number 1 by 4, because it should become 2, 4, 8, 16, right? Shifted to the left by 4 is the same thing as multiplying it, doubling it 4 times in a row. My brain can't work like that. Let's just shift it 2 bits, because that's multiplying it by 4. So, let's do A1 is equal to the number 1. Our shift value is equal to 1. We're just going to test that out. And by the way, this one was a shift to the left. We're probably going to need to recopy and paste this entire function, except we're going to change the format of this one. We'll see how that goes. And then call shift bits. A2 is equal to shift underscore bits. I see a couple more things I need to do. Sorry, A1 comma shift in parentheses. Now can someone tell me what's wrong with this call? This call would be a syntax error because of this line. That line and this line do not match. What is wrong?
You're calling A1/shift.
It's expecting one argument because there's only one parameter variable, but we're passing it 2. So we need to delete this line right here. Sorry about having to delete something in the middle. I wasn't hoping to have to do that. I guess I'll just comment it out. That's the line that I just commented out right there. Please nuke that, or else it's not going to work.
Nuke that?
Yeah, delete it. Comment it out, whatever you want to do. And then I'm going to need to add shift as one of the parameter variables, because we have to be able to pass it in. So I need to modify my definition.
And you can uncomment it out?
Oh no, I'll delete these comments eventually when I like my code. And then let's print A1 comma A2 comma shift, just to make sure that we like what it's doing. Because if I pass in 1 and I shift it 1, shift it to the left 1, which is what we've done, it should become 2. And then if I change shift to 2, it should become 4. So we'll test it a few times. Yeah. So let's shift it 2 and watch it become 4. Seems to be working. Let's shift the number 13, just for funsies, make sure it doesn't crash. Any number up to 255 will be able to be shifted with this algorithm. Why do I say 255? Because that's a max value of 8 ones in a row. And we could get up there and draw them, but that's a 1 plus a 2 plus a 4 plus an 8, 16, 32, 64, and 128. If you add all those up, you get 255. Let's make sure it doesn't crash if we do that. I'm not going to test it for a number greater than 255 just because I internally know that that would not work. So 255 shifted by 1 is still going to be 255. Why do I say that? Because if that's your string, you could shift it a zillion times and it's always going to be 1, 1, 1, 1, 1. But just to make sure it doesn't crash. All right. Seems to be working. Seems to be working, but we need, I think, well, according to the problem, which I'm kind of, not wanting to follow too carefully anymore, Where was our coding problem? It's probably told me it took too long.
My name's Dave.
Oh, they were hard coding it to 1. They just wanted to shift it one time. One to the left and one to the right. We are way more awesome than they are. We made it so that you could shift it any number of bits you wanted, up to 8. But this is a shift to the left, and we're going to write a shift to the right. Sounds like the Rocky Horror Picture Show, if you're familiar with that. So copy all, rename this to shift left. Copy and paste it, call it shift right, and the line that we're going to have to modify is this BS equals BF shift stuff. So this is shift to the right. You saw what I did is I just copied all that shift to the left. Oh, no I didn't. I cut it. That was a mistake. So I need shift left and shift right here. This would be a good time for those who are actually trying to get it to work to help with syntax errors and stuff like that, because I'm sure, yeah, so shift bit says none defined. That's because I renamed it shift left. So since I renamed that function shift left, I need to come down here and rename the function call to shift left. All right, working for me. I want it to be working for y'all, for those of y'all who are trying to get it to work. We are going to have to fix this line right here. So I'm going to just put the comment oops right there. I'm going to cut this one and paste it above shift to the left, just because when I'm helping y'all fix your errors, it'll be nice to have the whole thing on the screen. And shift to the left is the one that we know is working. Okay. So let's pause, those of y'all who are getting this to work. 55 is the largest number that we could do this 8-bit shift trick.
Yeah,
because we've hard-coded it 8 here.
Yeah.
And that's the largest number that we could hold in 8 bits. If we wanted to do some tricky stuff to where if the number was larger, we shifted it 16 bits or something like that.
Okay, yeah, because 255 and 8 bits would be just 181, so no matter how you shift it, you should always get 255 back.
Right, exactly.
Okay.
Right. Okay, we're almost done with our problem as they've asked, but like I said, I'm not expecting us to actually do this problem for credit. But it's been an interesting problem for me. Instead of A1 just being a number, it needs to be a letter. The ordinal value of a letter that we pull from a string. Just like in those Caesar Cipher problems. So let's get our input string. S is equal to hello, or let's do something A, B, C, D, whatever. This output is going to be garbage, by the way, because it's going to have non-ASCII characters in it, characters greater than 127. But we ought to just stop here for that purpose. But anyways, let's do it. For CH in S colon. In other words, for every character in that string, let's just print it out. Print, parentheses, quote, shifting, end quote, comma, CH, so that we can watch all the characters go by. And A1 is not going to be equal to 255, it's going to be equal to the ordinal value of CH. So change that line, A1 is equal to ordinal value of CH. We're still going to shift by 1.
You might want to change that to S.
Nope, I'm liking S right here, and this is CH because we're iterating every value through
not
it.
what I meant.
What have I missed?
You need to change that to S, or else, and you need to put it before the loop, or else it's going to give a syntax error.
It's not going to be a syntax error, but you're right. We don't need to redefine shift every single time. So I am going to cut that shift equals 1. Good call, Nathan. Let's cut that shift equals 1. Sorry for the cutting. Let's paste it above the for loop and unindent it. So this line just moved. Why are we doing that? Because we don't want to redefine it every time, because it might be a user-specified value. It's just that that particular problem specified a shifting of 1. I really hope that I didn't go absolutely haywire on this. No shifts of bits in its input, 1 to the left. That's what it's supposed to do. No, come on. You know what they were really doing? They weren't doing bits, they were doing a string. And we did that. We're going to finish our problem the way we did it anyways. Okay.
That is just so.
So, and let's change our print statement to say CH, comma, A1, comma, A2, comma, shift. Just so that we can watch this stuff go out.
It's gonna be like.
Shift the bits. And we're shifting the characters, not shifting the bits. Okay. So, they shifted A. 65 became 130, right, because it doubled. 66 became 132, 67 became 134, 68 became 136. And if we turn those back into characters, it's going to be garbage, because you can't have a ASCII character unless it's extended ASCII greater than 127. I'll prove that to you by going back to ASCIItable.com. Well, we could have stopped 15 minutes ago if I had looked at that and saw that they only wanted to shift the string and not the bits. All right, but anyways, you see that the ASCII codes really stop at 127, and the useful ASCII codes, the ones that we could type in on a typewriter, go from between 32 to 127. Anything below that is a control code. Anything above that is a graphics character. So we're going to see some weird output when we print it out, but why not? Let's convert A2 back to an ASCII character. So CH2, just to differentiate it from CH, is equal to CHR. Is that correct? Yeah, it turned purple. Parentheses A2. That gives us that new ASCII character. We need to be building a new string by adding character 2 to the end of that string. So like output plus equals CH2, but the only problem is I don't have a string called output up here.
It's called S.
So I'm going to make a string called output up here. Output equals empty string. No spaces between the quotes. So I just added that line as well. And the last thing we're going to do is we're going to print our output down here, just to see what kind of non-ASCII stuff we get out of it. So print, parentheses, output, in parentheses. The output is completely blank.
You need to print it out.
I thought I did.
You printed output.
Yep, and that's what I wanted to see. We were supposedly adding that character to the output each time. Tell you what, let's not bother with that, but let's print out that CH2 as part of this entire rigmarole here. So, we're going to do a little bit of editing. Just copy that line, that print CHA1, A2, comma, shift, paste it, and make it say CH2. And then comment this first print statement out. I mean, I guess we could leave it. Okay. And we're going to end this little sojourn right about here. That CH2 is winding up to be 1 each time. The ASCII value of it seems to be converting to 1 each time.
Wait a second.
I don't see why.
Can you print the output in the for loop?
I could. That would be fine. Just to see what is building up.
Oof.
Well, I guess I'm just going to accept that since these are non-ASCII characters, since they're greater than 127, then what it's printing out is just garbage. So let's leave it. Okay, so we had some useful concepts out of here. What did we have that was the most useful? I want you to remember the idea of writing functions like that, right? Very important to be able to write a function, passing in parameters, returning a value if it needs to return one. That's of critical importance. Using slicing to build strings or arrays, lists is what this language calls them, is of critical importance. Let's do their problem now, which would have just taken like 4 lines if we'd stuck with it. Which is, they just wanted us to shift the string. And we went to the trouble of turning the string into bits, shifting the bits, and then trying to convert the bits back to a string. We don't need to do that. It's just going to be this business right here.
Mindtap's a whole bunch of...
So what we're going to do
You know, I'm
is
not
we're gonna say,
it's a bad word.
just to help me work this out in my brain, I'm going to copy that line of code. So our BS is going to start off with the word hello world, exclamation mark in it. Our shift value is going to be 1. We are shifting to the left. We're going to do that, and then we're going to print out the result. 4 lines of code would have solved their problem. Great. Okay, anyways, I still think we covered some good concepts here. Yep. So if you wanted to do their problem, and why not, I'll solve it with y'all. You can take the answer and get credit for it. How about that? Because we worked 40 minutes on this. May as well give ourselves some Mindtap credit for it.
We did it in class, so...
So, I'm going to flip over to Mindtap and actually write this. So shift to the left. That was our shift to the left code right there. I don't know if you can see that, and it's not letting me zoom the text in. I have an extension that'll do that. I don't know if it'll work. Nope. All right. Can y'all see that, or do I need to go back to the other one? That's the shift to the left function. Here's the code for it. If I can get it down here, right there. Except we don't want to say BS is equal to hello world. We want to ask them for the string. So we're going to change this to an input statement, matching this question here. So I'm going to steal that question right there. I'm going to copy all that and make it say BS is equal to input parentheses that. End quote. Got to get the end quote in there or else it won't compile. Got to get the beginning quote there too. I swore I typed it, but apparently I didn't. Alright, so that's a shift to the left. And just to be able to run the problem, I'm going to copy all that and paste it into shift to the right as well. It's not going to work, right? It's not the answers, but I'm going to do it anyways. So I'm going to, just to get it to a state where I can run the test as soon as possible, I'm going to take this code and paste it here so that I could then run it. Where's my blue arrow? There it is. Okay, good. Shrink this a little bit. Run it. Enter a string of bits. Hello. Wait. Hello. And it did shift it. All right, let's work through how we would do a right shift. If we have this word, Fred, and we want to shift it 2 to the right. What are we going to have to do? We're going to take those 2 characters. No, we're going to take these 2. How are we going to do that? I don't know why my brain works with shifting to the left better than shifting to the right.
The F and R move forward and the ED go where the F and R were.
Yeah, so the last 2 characters need to be appended to the front. Whereas the last time we did it, the first characters got appended to the back. So it shouldn't be too hard. Same calculation, I believe, or pretty much. So the last part is this string starting from the length, what if this word was breed? It's 5 long. No, it's 5 long. We want to take the last 2 because that's our shift value. So we need to know that we're doing 3. So I think 5 minus 2 is 3. I think the length of the string minus the shift value, which is just going to be 1, is equal to the number that we need to get here. That would give us 2. Why is my brain breaking on this? This problem is as easy as the other one. But we need to excise these from it.
You mean 3 on that one?
We need to take the first 3. Yeah, I think that's the trick. Maybe we got it. Okay. So over here, instead for shift right, instead of shifting like that,
Can't you just shift it to -1?
Oh wait, Python does support that.
I don't know if that'll work. Let's give it a shot and see what it does.
That's decrement.
Here we go.
There we go.
Let's see.
Hello.
You're a genius. Why did that work? I don't know. I'm willing to run with it. To me, it looks like it's working. So,
Because the first part there, when you put the shift to -1 starts at the back end of the string. So you bring it back in first. Plus, if you're going from 0 to -1, then you put the front end of the string.
yeah, I'm just surprised that the algorithm that I made is robust enough to have actually handled that. Alrighty, so let's run it.
Give it some different.
Run the checks.
See what happens.
And it worked. Oh my gosh. Okay. You are a god. Alrighty, so that's all we had to do. I'm not going to worry about why. As long as you have the concept of slicing and what I did here, which is to start from a specific character and go to the end. Oh, and I see why it works. The reason why it works is because this is the only language where you can get away with doing stuff like this. If you want the last character of a string, if you want that D, then you can do this. Start from -1 and go to the end. No other language I've ever seen lets you use negative indexing into it.
The other ones have to make you specify what you're shifting.
Yeah, and so if you want the 2, if you want the last 2 characters, S -2, colon, like that. Cool. You can come teach the class. I'm happy. Happy you figured that out, rather than the way that I was about to do it. Alrighty. I know that at least half of y'all are wishing that we hadn't done this. What were the important concepts? The slicing,
Are you putting those in our notes?
the idea of using a for loop to step through a string. That's worth doing just all by itself down here to reinforce it before we're done. If I have a string like that, and I want to print out all the characters in it, use a for loop. For ch in that string, print ch, and that'll print h on one line, e on the next, l, l, o, and so on. Right, just like we're seeing here, like that. Very important to be able to do that. The other thing I want you to be able to do is the idea of defining a function. def fun, like let's take a string and maybe loop and print it out that many times. So s comma 2, so def s fun s comma 2, and we're just going to have a for loop. For x in range, why did I put 2? This is supposed to be num, the number of times we're going to repeat print this. So for x in range, num, colon, print s, print parentheses s. And so if we want to print out hello world 5 times, we can do that. Just call fun bs, comma 5. That invokes this function, passing in this argument bs, which contains that string, to there. Notice they don't have the same names, and that's okay. This is just a local variable that's a parameter variable that picks up the contents of this. And then the 5 gets copied into that variable, and it uses those in the for loop to print it out 5 times.
Oh.
Just like that. Hello world, hello, hello world. So 5 times.
And it also spliced it.
So, and the slicing of hello world, if we want these characters from here to here,
You just
that's
did that.
starting at 0 and going up to which index? Well, it's 5 long. So starting at 0 and going to 5. But if we actually count them out, that's 0, 1, 2, 3, 4. Just a reminder of the actual positions. But if I do this, print, wait, I better do it up here before we violated what BS is.
What?
Print, parentheses, BS subscript, starting at the first character, and I could leave the 0 out if I wanted to, and going up to character 4, so I have to go 1 past it, just like slice, just like the range statement. This goes out from 0 to 4, 0, 1, 2, 3, 4. That'll give me the first word. And let's get the last word. What position is that? Well, starting from the beginning, that's 0, 1, 2, 3, 4, 5, 6. I could do it that way. And then going out to the end. Print BS6, starting at index 6 and going out to the end, like that. Or I could count backwards. That's -1, -2, -3, -4, -5, -6. Okay, that's a coincidence this particular time. But if I print out BS slice -6 colon going to the end, it'll also print out the word world. So this is going to print out hello. This is going to extract, it's going to slice the last part starting from character position 6. And this one's going to do the same thing starting at position -6. Let's run it. And it did so. Hello world world.
Hello world world.
Okay, so slicing, that's the point. Defined functions, that's the point. For loop, I don't know why I did those in caps and this one not, but the for loop to iterate through a string, that's the real point. If you didn't get anything else out of the hour and 10 minutes that we spent on that, please get those things.
I think next time we can learn how to do inputs into a for loop.
Yeah, absolutely. Absolutely.
Because I just did that. You enter some numbers and it would count it down using a for loop.
Oh, yeah? Cool. Cool. All right, so done with this. I'll bring that back up, don't worry.
I'll bring that back up.
There. We're going to make that one the third programming exercise, which, if you just copied what we did, you already know, or you can watch the video. Thanks. Okay, I'll do that in a minute. Anyways, as a reminder, what we mentioned at the beginning of class, out of sheer frustration, the Mindtap assignments are going to be removed from Canvas and just turned into a folder that looks like this. Mindtap Programming Chapter 2, 1 through 4. Upload a screenshot of the Mindtap page showing the problem's done, right? And then there's going to be one for Chapter 3 and there's going to be one for Chapter 4 that say the same thing. So you're just going to do all the work and then you're going to take a screen snapshot and you're going to get the credit for it. And then if you go back and do more, take another screen snapshot. And even if you've already done them, go ahead and take the screen snapshot, right? Yeah, let's just leave it there. I'll post an announcement to that effect. Alrighty.
Some students are going to take 4.